Okay, hi everyone. Welcome back to our irregular series on panels for Virwescon. And want to introduce everybody again. I think you probably know all their names by now, but it's really good to get a handle on who's who. I'm Tracy Furutani. I teach physics at North Seattle College. Charlotte?
All right. Charlotte Lewis Brown, paleontologist, teach natural disasters of all types at Green River College and do books on disasters as well.
Dr. Ricky?
Hi, I'm Dr. Ricky. I am struggling with coronavirus situation. I am a research scientist, but I write about food to help educate people about science.
Colette?
All right, I'm Colette Brashears. I'm a natural gas analyst at Wood Mackenzie, but dabble here and there in all different kinds of science. Studied geology for a long time in the Pacific Northwest.
And Jake?
High school science teacher here in the Seattle area. Pretty much everything at one point in time or another. So.
Well, thank you all for participating in this. And the topic today, broadly speaking, is climate change, and specifically human impacts on climate change. So it's a really humongous topic. And so I just want to throw it out to the panel now. What incredibly depressing aspect of this do you want to talk about?
Well, the original title we were going to go with was Surviving Climate Change for Dummies. So, yeah, the long term, that's going to be difficult. But I would throw out not just what's happening, since there are news articles about that, but what might be some creative or just practical day-to-day things and long-term things we can do to try to get through this as best as possible.
Make sure you have a towel.
It only works if the aliens are coming by and you can hitch a ride. Oh, you got a towel. Excellent.
Look at you, Ricky. I was unprepared. I'm sorry.
He wins
You
the
can drown.
I'm out.
All right, so I guess that's a really good place to start then. So one thing I've shared with you, for those of you who have access to the chat, there, a friend of mine, Heather Price, she teaches at North Seattle as well, and she's been a leader in getting climate science into the classroom at our college and at others. And she made a dress that uses the IPCC data on the excursions from historical norms. And so I don't know if I can put this up on screen and share it with you guys, but I'll give it a try.
It's hilarious.
You should be able to.
Yep, I can't share screen. Okay, but
oh wait, I'm sorry. Like I say, I'll edit this part out. Try it again.
All right, perfect. Okay, so this is what you're seeing is her Twitter feed, and I'll just scroll down to the irrelevant bit.
Yeah, she does a lot of workshops for both faculty and for general public, for kids especially.
So yeah, if you're looking at her dress, it's a very attractive dress, basically blue on top, kind of reddish on the bottom. And the idea is that the colors, the heat map colors, indicate if you're colder than historical norms, then you're blue, and deeper blue means colder. And if you're red, it means warmer. And so if you look at the dress as a whole, recent is at the bottom, and I think 1800 or so is at the top. So each stripe represents a year. And so you can see kind of the distressing fact that she has a very nice red hem. So this is what we're talking about, is the fact that since the Industrial Revolution, of course, average worldwide temperatures have gone up something like 2 degrees Celsius, depending on who you ask, on average across the world. And so the question for the panel then is, let me unshare here, what do we do about this? So there's long-term and short-term solutions. Anybody want to take a crack?
I mean, do you want to actually change the trend, the climatic trend?
Well, I mean, me personally, sure. I mean, I don't know if it's practical at this juncture, since we now are behind by about a couple hundred years, but still.
Buy water wings.
Well,
Start building your rafts.
The problem is fitting the dynamic of people being able to grasp what climate is. I mean, teaching that in high school science, one of the things I always told the kids is humans as a whole have a really hard time with climate because we consider climate to be a change over a course of, say, 100 years. Now, of course, we're seeing it happen faster now, but even so, a change over 20 years still is over such a long period of time that people tend to shift to the new norm. Does that make sense? And so we can't tell the difference as a conceptual organism. We have a hard time telling the difference between climate and weather. And so when it's a really cold winter, oh, well, so it's not, see, the weather's not warm enough after all. The same people the next year, it's a hot summer, oh, maybe climate change is real. They can't grasp that difference between the two. And until you change that dynamic, it's hard to convince people that there's actually a big picture change that's outside their life.
One of the cool things that Heather, I've seen her workshops, I've been working with her for climate justice, because the point is that it's not just an abstract thing that affects everybody, but climate change is going to disproportionately affect people who are already struggling, both on a global scale and on a national scale, and on a local scale, I guess you could say too. But she has a couple ways she tries to get to, especially high school students, try to understand what's happened. But she points out in her lifetime, if you look at the graph of temperatures, there's only been one normal year. You know, she was born essentially in the 60s. So everything else has been above normal, if you count the normal as 1950. So that's one problem. I know people are arguing it's a lot easier perhaps to get some people's attention if you point out that coffee is one of the crops that has a large impact on the climate, and large amount of energy goes into producing a cup of coffee, transporting it and so on. And it's also in a lot of marginal areas. So you either triple or quadruple the price of coffee, or maybe you don't get coffee in the morning every night. And that sometimes makes things a little bit more real. I don't know, so I'd maybe throw this out. What other things can you think of, if we can't stop it, we'd love to stop it, but it'd be difficult. How do we actually?
Well, that comes down to what we think of as the problem, right? If we think the actual change in temperature is the problem, that's kind of a geoengineering level issue, which by the way, I'd be interested to know what the results are for next year, given that the whole world pretty much shut down for this year. And there's a huge impact on air pollution in the seas and stuff like that. That's, we won't really know that until next year. Maybe we will have a dip in our global climate model if that happens. But is the change in temperature the problem? Is my question.
It's one small part of the problem.
So, so this is something I have my ideas about, but I'd really like to hear what other people think. Colette,
Dr. Ricky, go on. What are the other aspects that you think of that are, if not more important than temperature, at least equally important as?
I think the real problem here is speed of human adaptation, because this is not the first time the entire planet's climate has changed. I mean, we've had a wholesale atmospheric change, pre-oxygenation and post-oxygenation, and like, okay, that granted, there's like a huge extinction. There are huge extinction events that happen to do that, but that also means that it produced for every extinction, there is an opportunity for something else to evolve. So it's like kind of the problems I see there, it comes down to human responsibility. like I think the hardest part here is like convincing people that humans are responsible for this.
Sure.
And that humans have to figure out how we adapt. Like, do we care about the small nations that are literally going to lose their land within the decade? Do we care about the most impoverished parts of our and if we do care, who's going to do the caring? How does that show up? How do we hold them accountable? So that I think is more of the problem. The question of slowing down the temperature is buying us time.
So you're saying that our own human resilience might be a factor in why we don't deal with this problem on a time scale that is meaningful.
Because if all you care about is the time scale of one human life, it's irrelevant, because it'll be a blip, you know. Mm-hmm. So do we care about it in generational terms?
All right, panel. Basically, he's thrown down the challenge. Do we care about it in terms of generational terms? I mean, what can we do? There's a chat question here basically about, what's the human population growth contribution to the problem, and how can that topic even be addressed without being accused of negatively perceived eugenics? There's your generational question, right?
Mm-hmm.
Let's hear from the youngest panel. It's gonna be around longer to deal with this. I'm out, man. I mean, I've got like 10 years left. Colette, it's all you.
Oh, we are screwed.
I was trying to avoid that answer.
Jake, you prepared her well.
No, I tried.
I'm done. I'm out. Boy. I don't know. Like there's so much that we can do, I think, to start addressing it. I think the difficult part is scaling the response from the individual level through sort of like, if you think about like the bubbles that you live in, you have your individual bubble, like your friend group and family group bubble, your city, your state, your country, maybe even your continent, or like a European Union or something like that, that you're a part of, and then those also cooperate on a larger scale. Right. So the biggest question is, what can we do as individuals and as sort of like our smaller bubbles, but then what can we also like proceed with on sort of those larger scales? Because this is not a problem that is local to the US. It's not a problem that's local to Greenland or Europe, Spain, like Italy. Think of all, or Africa. South Africa, Australia, like if you think about all these disparate regions, they're all struggling with some version of climate change. And they're having to do that at a very regional level right now. And there are some aspects of the world and some momentum towards both sort of the global study and understanding of what is happening, what is causing it, as well as what can we do to slow that down. But we'll also need to have that global buy-in to fix all of this. And this really gets into politics because it's intertwined with how countries are relating to each other and how, like, and really if you have 80 good actors and 10 or 20 bad actors, that can continue to keep the equation balanced, even though you still have like the majority of folks or countries or bubbles that are doing these good intentions or are cutting back on like their greenhouse gas emissions, are implementing standards for emissions into the atmosphere, that kind of thing. For as long as there are folks who are not participating in this, we're going to continue to have a problem. And I'm trying not to get too political about it, but it is going to be a global issue. And I think the biggest question is, how can we set up these structures that will be longer than one human lifetime or one presidential term, or even like a set of presidential terms? Like if you think about how many presidents or administrations the United States has had since the 40s, there's been so much radical differences that have kind of just come and gone even. And how do we make climate and addressing the climate issues something that sticks around beyond even the next 10, 20 years? It's possible that we won't have to do much because it's going to become an issue that cannot be ignored. It's, in my opinion, it's already there. But
It goes away with the hot weather.
yeah.
Well,
Because the people die and then they're not making the carbon dioxide anymore, and then there's no more hot weather.
you forget
but then your
decomposition.
wildfires. Wildfires are part of it too. So wildfires just make the hot months hotter.
Well, how do we
Actually,
adjust?
they make the hot months colder for us because the smoke blocks the sunshine.
That's fair.
It does actually mess with the weather forecast. I'll say something, Jake, and then let you go. Just
Go for it.
to your point, Colette, I had an office mate way back when in the dark ages when I was in school, whose actually thesis was trying to figure out when the economic tipping point might be. The premise being at some point it'll be more expensive not to deal with the climate change. In some ways that was a little bit naive because there are certainly a lot of people adversely affected, like you say, island nations being flooded, people who are losing their nations. And the people most adversely affected don't have the money to do something about it. But if you can make it economically advantageous to do something, that trumps the moral every time. Now that's a little bit trickier, but that's one reason why I've been really interested in following like the advances in solar power, which make it more efficient and cheaper. We get to the point, and we were at the point in many parts of the U.S. before coronavirus hit, where the majority of energy, certainly for Washington State, was from renewable resources. About half, a little bit more. Will that survive crises though? That's the question. What were you going to say, Jake?
Well, I guess the thing too is we're looking at solutions that are high technology solutions. So like solar power, we're trying to figure out the technology to make it a factor that can be easily used and efficient. How do we function that in the picture of countries that aren't that technologically advanced?
Actually,
and their population is not, I mean, do you just share it? I mean,
there are some really cool low-tech projects with solar power. There is a project, essentially, they created an oven out of a parabolic mirror. So it's a solar oven. And, you may be only to cook a couple potatoes at a time, but you can then import it to places that have been deforested where there's not a lot of wood. And people were still cooking with wood stoves. You get that out and you can, help the landscape and help the people at the same time. And the whole trick though is to do it cheaply. Cheap enough that anybody can afford to do
I
it.
would love to be there for the presentation. Like, and here are your 2 baked potatoes.
You can boil 2 cups of water at one time.
But I kind of noticed that the discussion is all about, again, considering the change in climate itself as the problem. Like trying to figure out human responsibility. Because what this does, all these solutions are great, but they're not going to, it'll buy us time. Let's say we implement it, it'll slow down the change. The change will still happen.
I think part of that, the driving part of that conversation is it's so much easier to address the symptoms.
Mm-hmm.
And the cause, I mean, we generally know humans are the cause. That's pretty clear. With the Industrial Revolution, we started to see the data change. We've seen it increase since then as we've kind of continued the Industrial Revolution and gone into sort of the technical revolution. I'm not sure what this period we're in now is called, the age of the internet. But it's much harder to solve that at scale, and much harder to kind of say, well, the problem is that we are precipitating these changes in the earth, And even if we can change something now, we may not see those effects for 50 to 70 years, if then. And until then, we're still kind of feeling the effects of what was done 20, 25 years ago. So it's a lot easier to kind of talk about like how, like the small steps that we're taking now, because it's hard to, at least for me, it's hard to wrap my head around like, how can I fix what has happened 30 years ago? It's already been done. There's a hole in the ozone layer. What can we do to fix it? And so that's really kind of like, it's the problem solving aspect, and people in general just, I mean, I'm one of them. I problem solve, but I can't really problem solve something that is hard for me to understand or grasp the enormity of it or the time scale. And I have the advantage in that I spent a long time studying rocks, and there's nothing like rocks to make you feel pretty insignificant on the time scale. So
Well, one thing that you pointed out, the Montreal Protocol, which started phasing out the CFCs that were destroying the ozone layer, was in, I think, 1987. And it was actually an incredible landmark of international cooperation. I think the thing that made it happen, though, was, I think somebody mentioned the economic aspect of it, which was there was an alternative to Freon that was actually not as harmful for the ozone. And so you could get the developed countries buying into doing that, have the developing countries buying into that, saying, okay, we can use Freon for a bit longer, and then we'll phase into this other more expensive stuff. And even the non-developed countries were basically saying, okay, we could start off by using this stuff as long as you subsidize us. So there was an incredible amount of economic cooperation, which I think underpins all of this discussion of, as Dr. Ricky was pointing out, the human response to basically something disastrous. The question I have for you guys then is, what's the economic driver for this? And I know, Charlotte, you mentioned something to the effect of you have to have like a nice alternative. You have to have basically some make it more expensive not to do something about this. But what is that other thing?
If I knew that. If only I knew that.
I have a comment for this actually. There has been a movement among organizations to support environmental and social justice, right? And that's actually been something, it's not just sort of, it's not constrained to just environmental organizations or social justice organizations. It's something that we're starting to see on the behalf of investors, of banks, of the large hedge funds, basically the source of all of the money that is driving these companies. Like we have large movers like Coca-Cola or Nestle that are backed by banks like Wells Fargo or JP Morgan. And we're starting to see those investors come back to the companies and say, wait a second, what are you doing and how are you taking these issues into account? And those are starting to influence the investment decisions. We've seen, speaking from sort of what I've seen on the oil and gas industry side, we've seen a huge shift in the available monies for oil and gas exploration companies, for development of other technologies. And it comes back to, how are you mitigating the harm that you're doing? How are you of developing out new technologies to avoid doing the harm in the first place? Or like, how are you transition or helping to support the energy transition to cleaner fuels? And so that has been something that the investor banks are coming back and asking to these companies, and that's driving these companies, like they have to consider it. If they don't have a good enough answer to that, they don't get the money lent to them in the first place for them to start their operation. And I think that that's going to be a big driver, as long as we can keep that conversation going on and encourage the, essentially the Wall Street. And if we can encourage those investors to continue asking those questions and to highlight the fact that being environmentally and socially responsible is going to be a factor of being able to do business, I think we'll start seeing actual changes come from that. So
That's something your everyday person doesn't know is happening.
Yeah, it's like there's hints of it here and there, but I know it's not my favorite part of my job, reading through hundreds of pages of earnings call transcripts. But if you have a lot of free time and aren't sure what else to do with it, I mean, it's worth taking a look into some of these. You can skip the scripted part, skip down to the question and answer section.
So do you see anything like a Mr. Fusion there in the stuff that you've been reading?
Oh, I wish.
You know that to build a Mr. Fusion, you had to generate like 3 million tons of coal per unit into the air or something like that.
Yeah, but then once you have the final results, as long as you can convince them it's good, you can.
Oh, and plus the carbon tax that would go into time travel. Geez, I mean, you think air travel's bad? How many? Like 88 gigawatts.
You just time travel all that CO2 back into the Precambrian, where a little bit more would not really have been noticed. Get it to convert back into plants.
See, now
and then it will become our fossil fuel of today.
There we go. It's renewable.
that was the somewhere out there.
That
The
hurt.
small thermodynamics will get violated and reconstituted over and over again.
Sounds fine.
What I like are the small scale solutions. People have yet to figure out how to make it economically advantageous, but things like solar cells that you could put in sidewalks. So there was one project, which I'm dubious if we'll ever get there, but it was a cool idea that you have.
Somebody did try to implement that.
No, they've had tests.
It didn't work.
No, well, of course it hasn't worked.
Well, one of the ones
What did people driving? Well, it was solar cells under essentially a clear surface, and you'd have roads or sidewalks made out of it.
One of the ones that was interesting though was the pressure plate experiment in Europe. I can't remember which country in Europe did the one where the roads had these plates in them that as you drove over them, it created an energy release that was then collected. And it's like it was a great idea, but I don't know. It was a short-lived test, and I don't know. Never heard much of anything about it, but it would be interesting.
You're never going to get the full energy back, but I guess the idea is to recapture some of the energy that went into the
brakes on a
gasoline.
Prius.
Yeah.
Okay, so my pie in the sky idea was, if we have all this excess CO2 and we have the ability to transport it, which we don't, is to move it to someplace like, say, Titan, Saturn's moon, where you could actually get it converted back into methane essentially for free, because the equilibrium drives it to be in the reduced form, not in the oxidized form. And then we could just sort of have this shuttle going back and forth of Titan sends us fuel, we send them our waste products, and it gets renewed. Now, the only part that basically is the difficult part is getting things out 10 AU to Saturn, but there you go. That's your
I
part.
love the only part.
I've got a solution. All we need to do is just send it to Mars, and then it can become Mars's new atmosphere, which will then hold polar caps, and then it'll create an atmosphere around Mars, and then eventually we'll have a 1 ATM atmosphere around Mars once all the polar caps melt because of our added carbon.
Right, and it's only 0.6 of an AU away. That's good.
Right, it's so much closer.
I swear 88 gigawatts is cheaper.
But we don't have a church everywhere that we can use for that.
Well, there's one set of thoughts that we should just pump it into the bottom of the ocean, and especially if you can get it into solid form, mostly your problems are solved. But to put it back into the ocean trenches, and then it's a couple million years before it'll come out of the volcanoes again. Because the whole problem is not that we've created new carbon, we've just changed the equilibrium between the massive amounts of carbon we have in the ground and the stuff we have in the atmosphere.
There's also the idea of just carbon dioxide injection, which is used a lot in oil and gas, where you capture the carbon dioxide that comes out of your drilled wells and you just process it like you would any other produced fluid. And they just re-inject it right into the formation or into a different formation. And it goes into deep storage.
Do you have I've heard about that just a little bit, but do you know what actually happens chemically when you pump that stuff into the ground?
There's a couple of different things that can happen. I know there's some studies going on what happens to it when you inject it into basalt aquifers. And that's going on in Idaho. It's part of the research that Boise State is doing. And so that's been one of the parts of it. The national laboratory there in Idaho has been focused on that a little bit. The other place that is doing a lot of science about it is Norway, as part of their Stat Oil, which I think is now Equinor. That's their sort of state-run oil company. They are looking for to be essentially carbon neutral while still producing oil and gas to supply their nation's energy needs. What they're doing is they're essentially capturing all of the carbon dioxide released in the process, and they're re-injecting that to kind of clean it from the atmosphere. And it's very interesting. It's very, I'd call it like leading edge. So there's not a lot of longitudinal science done around it, but there's a lot of thoughts. And there's a lot of studies going on what exactly it means when you do this. Because we've been doing it now for probably 10, 15 years-ish, but it hasn't been very widespread. And the research that's come out has been very muddled and biased. So it's hard to get an impartial observer in there to do the research.
Especially these days.
Yeah, it's very political.
A curiosity question, is there any way at this point in the topic to actually convince people to look at the science and not the politics anymore? Because climate change is such a political topic nowadays.
But, okay, Tracy, you're supposed to invite Greta Thunberg here.
Yes. she was super busy, so couldn't quite get her, but next time we'll try. But yeah, no, Jake, your point's good. Is that I mean, it would be nice to have a rational discussion about what anthropogenic climate change is about and what can be done. I know, Ricky, this isn't really addressing your point about the human resilience factor, but the fact is that, we do have a problem. People are more problem solvers than they are abstract thinkers. And so the question is, how can we use humanity's, talents to their fullest extent? And perhaps basically dealing with the Simpsons is not a terrible thing to do at all.
Maybe it's what we're better at.
No, because if you think of it, if you think of it as one problem, but there is a competing set of interests that look at it as opportunity.
Oh yeah.
So, like for example, Siberia hit what this year?
Fahrenheit.
100 degrees
Yeah.
Fahrenheit.
Nice.
Okay. In Siberia.
And it's 55 here. I'd like to point that out.
We just don't have enough global warming.
I guess not.
Well, I understand there is serious interest in figuring out where the Canadians are going to put their port for the Northwest Passage when it opens up. All that ice is gone. Lot faster to travel across the pole. Of course, it's going to be a mess ecologically, but
again, these are you can look at it one way as a problem if you're sticking to the status quo, or you can see it as an opportunity if you're embracing the change that's happening.
The question is, will human beings survive that change? Because
some human beings will.
Maybe. What happens when countries that are highly populated, that are going to be affected greatly by a disappearance of the ice caps? What happens when they need to move?
We're seeing a few big countries being hit by a huge, a fatality event happening right now.
What?
I have no idea what you're talking about.
We're kind of neck deep in it right now, so we'll see what happens.
Ricky, Dr. Ricky, you're in Houston, which is being affected by rising sea levels. I mean, have you seen anything that the city government or even the county government has been doing about that?
Tracy, you're kind of fading out.
Sorry.
there you are.
Okay, sorry, I don't know what I was doing. Any case, I was mentioning how you live in Houston, and is there anything that the city government or county government is doing to deal with rising sea levels? Because you guys right are at sea level.
No, we're not. We're actually some distance away. Where Galveston is close, but we are in the Gulf Coast.
Mhm.
Um, uh, this is one of those things that's kind of it's going to happen in New Orleans before it happens to us. It's sort of like the attitude for the local people, and and they've already been slammed by Katrina, and the levees have been rebuilt to the same specs in the 1960s. So Tim Harford. Do you know who Tim Harford is? He's a guy. He's got a podcast called some Uncomfortable Tales, or but anyway, it's all about bad decisions people have made.
Mhm.
And the point is that many things have happened in history that we have plenty of ample warning way in advance. Katrina was actually predicated by Hurricane Ivan, but 4 or 7 years prior to that. And it just missed by a lucky shot. But all the forecasts happened. They already knew what was going to happen. And in that time, people didn't make any changes in their behavior. Everyone already knew exactly what Katrina was going to happen.
I'm going to go one step further than you. I mean, we're in the middle of a big denial from a lot of people right now about what a risk is. But there was some interesting analysis done after the Paradise Fire, the deadly event in California, looking at the towns in the region that burned and pointing out, for example, like you say, there are plenty of warnings that this had happened. It was a place prone to burning. 2, had been getting drier. 3, there had been trees, bark beetles killing the trees, all sorts of things where if you look out your window, you could tell that the risk was rising. The city council actually voted to limit the width of the streets in and out of town because they wanted to enhance pedestrian traffic. So they actually narrowed the roads, which was part of the problems for people getting out. And so the article was an interesting look at trying to say, how do you get through our brains? There's a really big denial switch. If an issue is just too big and too scary, people just won't address it. And we see this with students a lot of the times.
Well, here's the question to that. Is that really, I think that builds, it's what we were talking about earlier, the whole idea that individually or to globally, it doesn't matter which scale you're talking out, people can't imagine something bad happening to them until it does.
Yeah.
We can't, Colette, you said we're a problem-solving species, not a dynamic thinking as a whole. And so if we do something that we know has a risk of being a problem, and it doesn't ever happen to us, we're like, well, then it can't be that serious. We're seeing it right now, as you say, with what we're going on with right now. We're seeing it with climate change. We're seeing it with so many things we do that until somebody steps in and makes a change from the top down, and then it takes a generation for people to actually say, okay, that was a good call. Seatbelts are a great example. Nobody wanted seatbelts.
Well, not nobody, but a lot of people did resist
In the big
them.
picture. In the big picture. So you look at that. Now we wouldn't go out without wearing them. Some people still don't, but
Yeah. I think the problem with climate change is, I mean, seatbelts isn't a great example, but ultimately, if you don't wear the seatbelt, you're the one who's affected. With climate change, your behavior is going to affect everyone around you. I'm going to throw out just a little bit of a different twist. What's the zaniest, I was going to say, thing, or the most interesting thing that you've come across in terms of ways we might reverse some ecological damage or some climatic damage? One of the ideas I thought was charming, although I can't imagine how it would work, was building materials with built-in algae. So this person had envisioned not just roof gardens to take care of the urban heat problem, but having the whole front of buildings being a green living surface. Now, given how good I am at gardening, I'd be a little bit worried, but I thought it was a cool idea.
Oh,
Cool thing about algae is that it's pretty resilient.
Yeah,
So
as long as, except it'd probably escape and take over the ecosystem, but
side effects.
anything,
I like
yeah.
the way she thinks. So
The idea of mirror between, or the blocking surface between the Earth and the Sun to block 5% of the Sun's incoming radiation. That would be an orbital structure that would stay in between us and the Sun and kind of, yeah.
Space mirrors, you can put Mylar up there.
Yep.
So have you guys ever been to the big cities in Asia, like Beijing or Mumbai? Well, Manila is probably the most congested city on Earth. Actually, I'm worried about like how they're containing the outbreak over there, but it's because if people live right on top of the other. It literally took me 2 hours to get an Uber to go 4 miles in Manila. But the reason I'm saying that is because the air pollution quality there is horrible, like really, really bad. To get around that, some of the parts of Manila implemented these plants on the side of the streets. Like, and they go into the underpasses. They put these green walls on the side. They're like, they literally have plants, gardening these things all the way up, supposedly to purify the air. Well, the air pollution is so bad they all died. But since they made a big deal about playing the green, they put plastic ones there.
No.
So
So they're using more resources to hide the fact. Oh,
but
dear.
the point here is that that's a problem with living things. Yeah, they can be pretty resilient, but they can only take so much abuse. For a while, so an interesting little piece of technology, like, which I kind of miss. I need to go back and find it. Way back, I think 5 years ago, somebody described a microalga. It's a one-cell algae. And the morphology is very interesting because most of the cell is one droplet of oil. Like, it basically converts things into a lipid, and it keeps a little droplet of oil. It's really microalgae. So they're like living little droplets of oil. I don't know, think like a salad dressing, only every little droplet of oil is an alga, and it's green.
Living salad dressing, even better.
Um,
Does it scream?
But what I like about this particular technology is that it's direct conversion from solar energy into high density chemical storage. And I think there were some problems about the resiliency of this microalga, like, but if you could have giant incubators of this stuff, and we could retool to the specific lipid hydrocarbon types that come out of it, we could change a whole lot of our industry to renewable. Remember this about petroleum, it's not just burning it. Petroleum produces a ton of products.
Yeah.
Not literally, but a lot of products, and we need those things as part of the output. It's just not a matter of we're going to replace it with solar energy, because just our plastics consumption is huge in that.
So yeah, one of the ideas that I've run across is a colleague of mine is actually studying artificial photosynthesis. So kind of in line with your idea. in the sense of coming up. There's a key enzyme called Rubisco, which
Yeah,
essentially
yeah.
fixes carbon, and she's trying to basically figure out how we can mimic at least parts of that enzymatic reaction. Because if we could do that at our whim, then we could actually start making some of these kind of plastic materials without actually having to literally, distill down hydrocarbons, et cetera, et cetera. So I think that's kind of an interesting idea, because you could take it a step farther and say, well, if the problem with using so many fossil fuels is we have to produce enough food to keep everybody fed and all that kind of stuff, then maybe this would be go a long way to actually taking care of that.
Well, we got to make it cheaper than actually pulling fossil fuels out of the ground.
Although that's getting more and more expensive all the time.
Not last month.
Well, let me put it this way: that's getting less and that's getting less and less profitable all the time. Your profit margin
Okay.
is dropping. But fair enough.
Right,
And I guess
Colette, did you fill your basement with oil at the time?
Oh, I wish.
I mean, they would pay you to keep oil in your basement.
Oh boy. So much of that was insane. That's really more on a failure of how markets are regulated. I think the fundamentals are still favoring exploration and development. So, but oh boy, that was insane. That was one of the worst half hours. Me and my entire team just sat around and we were just looking at that price for the WTI oil. First hit 0 and we're like, oh, that's new. Didn't really think it would do that. And then it went negative, and then it went negative into the 30s. And we're just like, well, someone is getting screwed. And it turns out it was foreign investors that could not take physical delivery of that oil.
Oh,
it's super fun. I can talk about that for hours. I'll stop right now. But it was fascinating to sit and watch while not being impacted.
nice. It'll never happen to us, right? Oops.
Sure. Just don't trade commodities. You'll be fine.
So I guess the question is, Tracy, as we look at this, the end is, so do we fix climate change, or do we simply roll with it and figure out how we're going to survive tomorrow?
Well, that's a great question for the panel. Since we're coming to the end of the hour, let's sort of summarize our thoughts on that. Answer Jake's question.
I'd love to fix it. I think even if we started with the best will and the most cooperation today, it's still going to be 100 years before we can really stop the changes that we see. And I'll point out, it's not just that the temperature is rising, it's you have climate's changing, and particularly precipitation patterns changing, and that, the glaciers melting, which took 20,000 years to put there in the first place. So how do you repopulate snow in Antarctica or Greenland? That's going to be really big problem. So I say we have to live with it as best we can while trying to limit further damage.
Colette, what do you think?
Oh, I think it's a two-pronged response. I think we need to, on one hand, be looking at what is driving climate change and really make a concerted global effort to stop it. How we do that, I don't have good solutions. It's going to be political, and it's going to be a mess. But then on the other hand, I think is addressing the symptoms and making sure that everyone not only understands the science of the symptoms. Like, it doesn't matter really if you believe in climate change or not, you are still going to be affected by what is going on. You can be a climate change denier, but the fact that you are living in California and you're seeing wildfires come through every single year, or in Australia where the wildfires were devastating and are, I think, starting up another cycle. Like, it doesn't matter whether you believe in it or not, you're going to be affected by the symptoms. And so I think communicating how to deal with those symptoms and really making sure that there is that regional response to those symptoms is excellent. I posted in the chat, Galveston is 7 feet above sea level. There's been a couple of times I've been down into Galveston, and there are markers on the walls of how high the sea level got during certain hurricanes. And they're just like, yeah, like here we flooded to this one. And they're like, oh, if you want to see, you know, the Hurricane Harvey total, you have to go outside on the front of the building because it was flooded up above this floor.
Yep.
And you can track that over time. That's a very local way to look at it. But at the same time, as we have rising sea levels, as we continue to see worse hurricane seasons and have stronger hurricanes when they do break, that's something that Galveston is going to have to figure out on a regional level. Does Galveston try to mitigate it just by, you know, building codes and rebuilding the city every time there's a nasty storm? Or does Galveston encourage its residents to go somewhere else with a higher land? And then the big question is, how do you determine what's safer? So
Right.
it's all kind of together, but I think there's different things that need to happen. And on some, like, I think a lot of these conversations are starting to happen, which is encouraging for me. That gives me hope that we can solve some of these problems before they get out of response.
Mm.
So
That's,
Before the water's over our heads.
yes.
Yeah.
All right. Dr. Ricky?
I think the problem still comes down to education. The problem we want to combat is straight up science denialism. And Colette is right. I am gratified that we can, that the conversation is going on, but we're still fighting a lot of the denialism. It's still more pervasive, and there are people who double down on it. But ultimately, this is a species-wide, generation-wide responsibility. It's not something that, you know, like one technology is going to solve overnight if no one's willing to take responsibility for it. And that comes down to education.
We're doing our best.
I think, believe it or not, this conversation is probably pretty important.
Well, I think
a
there's
tiny drop in a bigger wave, but we got to keep it going.
Well, actually, I'll just add one of the things that's an evolution I've seen in the last 5 years is the realization on the larger scale for the community that you can teach all the science you want, but it's not going to do any good to change people's minds a lot of the time. You have to, well, no, you have to
change their minds. It's
well,
the problem, right? There's a pre-existing model.
Yeah.
That got installed early.
Yes. Yes. But the realization that you have to come at it from a different way. I mean, scientists were sort of trained, you have the facts, you look at the facts, you present people facts. Obviously, no, it's not quite that simple. So what a conversation is among educators right now is, well, yeah, early is nice, but how do you get people to step outside of their comfort zone? How do you make it personal? And like I say, one of the loads of thought was, you know, take it down to a cup of coffee level to try to make it personal, tell personal stories. I think you have to use a range of strategies to try to communicate with people. But realizing that it's a difficult job that has to be done in several different ways and trying to think about it is something new. Actually realizing it's not as simple. I mean, personally, I shifted my focus when Katrina hit because it was obvious that all of the facts in the world didn't matter if we had a president who thought, you know, FEMA was doing a great job. You have to step outside the box and try to come at it from a new way.
I think one of the
mistake
things
was that it couldn't get worse.
Yeah.
I think one of the things that's caused the dynamic, especially with climate change, that is unfortunate, is that I remember videos we watched in class when I was teaching in 2000, 2003, 2004, where we were watching videos about climate change where they were doing scientific predictions based on modeling that said that if we reached a certain level of carbon dioxide by year 2020, Miami would be underwater. we've reached those carbon dioxide levels, and Miami's not underwater. So
Well, it depends on
unfortunately,
where you go in Miami, but
right, but I mean,
point
but
taken.
you understand? I mean, the videos they would show would be like everything's underwater. There's water in the streets. It's unlivable. It's the Venice canals, basically. And I think the problem is we have to be careful of showing worst case scenarios and instead show the coffee cup thing. Here it is on a little picture. Your one gasoline car combusts this much gasoline into carbon dioxide, which fills this many classrooms with pure carbon dioxide every month. Now you take that car and you put it on a bigger scale. You've got 1 million cars driven a day in the state of Washington, and then it gets bigger and bigger. Something along the lines of it's a little piece,
Hmm.
but if you then add the numbers, make it something that can't be looked at politically, but can be looked at in some way that, as you said, it's a cup of coffee. How does that one cup of coffee affect over the year?
Chocolate.
There you go.
Don't talk about chocolate. I'm not stopping.
So basically, I just posted on the chat, for those of you interested, there's a class at the University of Washington Bothell campus. It's called, Our Future as Told in Climate Fiction and Climate Science. For instance, I didn't even know clifi was a term, okay? But nevertheless, the two friends of mine, Dana Campbell and Miriam Bertram, teach that class. And the students really dug the class
Oh
because
yeah.
not only did it basically talk about the basics of climate science, but it also showed different authors' takes on how humans would respond to the whole crisis. And these books are very different. Some of them are older, some of them are newer, but they're all basically use climate change as a central point in their stories. So I figured, if you're interested, take a look.
Cool.
All right, and so on behalf of the panelists and myself, wanted to thank everybody for participating and for watching.
Thanks
All right,
so much.
thanks everybody for participating.
Nice towel.